Now the question here is the size of the population important? Notice that the size of the population is not mentioned in our discussion of the center, spread, and shape of the sampling distribution for sample means. From our previous discussion, we know the following. First, the mean of the distribution of sample means is the population mean, mu. The standard deviation of the distribution of sample means is sigma over the square root of n, where sigma is the population standard deviation of individual measurements. The larger the sample size n, the smaller the standard deviation. In other words, the mean from larger samples have less variability, so larger samples give more accurate estimations of the population mean. The shape of the distribution of sample means is approximately normal when n is greater than 30. This is true even when the variable has a skewed distribution for individuals in the population. If the variable is normally distributed in the population, then the distribution of sample means will be normal regardless of sample size. These statements are true regardless of the size of the population, as long as the population is large. In this course, we work only with large populations. To illustrate this point, we compare a distribution of sample means from two populations of different sizes. Population A, for example, has 10,000 newborns. Population B has 20,000 newborns. For each population, the mean and standard deviation of the individual birth weights is the same. Mu is 3,500, sigma is 500. So we'll make sure that the mu is the same and the sigma is the same, just to really show the difference between the population size. Everything's the same except the population size, so we can really get a handle on how that would affect everything. To create the sampling distribution, we selected 525 random samples of 100 babies from each population and made a histogram of the sample means. We did this twice for population A, so two of the histograms represent 525 samples from the same population. As expected, there are some differences in the samples collected just due to random chance. Comparing these two histograms gives us a sense of how much variation we can expect from the process of selecting random samples. Let's look at that histogram here. So it shows population A twice. They said they did the simulation 2 times. They're a little different, but basically, if you squint at it, like you can't see it perfectly, they pretty much look the same, basically. Little differences just based on chance. But notice that the histograms of sample means from the larger population B has a similar shape, center and spread, to the histograms from the population A. Kind of the same thing. This one's very similar. If you squint at all 3 of these, they almost all look the same. They're kind of the same basic width, the same height, The size of population B did not really affect the sampling distribution. So the main point here is that the size of the population does not affect the variability of the sample means. Size matters if we're talking about sample size, as we've discussed before, for random samples. But size doesn't really matter if we're talking about population size, as long as the population is large.